You think your project memory file overrides your personal one? It doesn't? They both load at the same time. Your memory files are a stack, not a switch. Welcome to the Atlas. You've written a memory file to give the agent context. This episode is about what happens when you have several and which one the agent actually listens to. You set a convention in your project memory file. You have a different one in your personal file. They conflict. Which rule does the agent follow? Most people answer, the project one overrides the personal one, because that's how skills work, that's how settings work. For memory files, that answer is wrong. Every session starts with a fresh context window. Two mechanisms carry knowledge across sessions, the memory files you write and the notes the agent writes for itself. Both load at the start of every conversation. And here's the surprise, they're treated as context, not enforced configuration. Instructions the agent reads and tries to follow, not switches that flip behavior on or off. So the real question isn't which file wins. It's what's in context, and how does the agent reconcile two instructions that disagree? A memory file can live in 4 places, and where it lives is its scope. The documentation lists the 4 in load order, broadest scope to most specific, and that order is not a coincidence. Load order is precedence order. At the bottom, managed policy, instructions your organization deploys to every machine. Above it, your home file, your personal preferences across every project. Above that, the project file at the repository root shared with your team through source control. And at the top, the local file, get ignored, just for you, just this project. The table lists them broadest to most specific. So a project instruction appears in context after a personal one, and the project file can sit at the repository root or inside the rules folder if you'd rather keep the root clean. Both work. Scope is governance. Your home file is yours alone. The project file is shared with everyone who clones the repository, so it holds team standards, not personal taste. Picking the right scope is a deliberate choice, not an accident of where you saved the file. The agent builds those project layers by walking up your directory tree, from the folder you launched in, up to the root, collecting every memory file it passes. And here's the load-bearing word, it concatenates them. It never overrides. Launch the agent in a nested folder, and it loads the memory file there, the one in the parent folder, the one above that, all the way up. Every discovered file is concatenated into context, not overriding each other. The order runs from the root down to your working directory, so the file in the parent appears before the file in your folder. Instructions closer to where you launched are read last. And within any single folder, the local file is appended after the main one, so your personal notes are the last thing read at that level. Files in subfolders below you don't load at launch at all. They come in only when the agent actually reads a file in that subfolder. Nothing is replaced. The broad instruction and the specific one are both in context. The specific one is just read last. Here's the sentence straight from the documentation. Memory files are additive. All levels contribute content to the agent's context simultaneously. Not the specific one replaces the general one. Both, at once. And that one word puts memory files in a different category from nearly everything else the agent loads. When 2 instructions conflict, the agent uses judgment to reconcile them, with the more specific one typically taking precedence. Typically, there's no guaranteed, deterministic winner between memory layers. Now the contrast. Skills and subagents override by name. When the same name exists at 2 levels, one wins by priority. External tool connections override by name too. Hooks merge. They all fire. Memory is the odd one out. It's the only one that adds instead of picking a winner. There is exactly one hard layer in the whole stack, managed policy. An organization can deploy a managed memory file that cannot be excluded by any individual setting. It always applies. Every other layer is a request the agent reads, not a guarantee it enforces. So if you need a guarantee, block this, always run that you don't write it in a memory file at all. You leave memory and write a hook, which runs as code regardless of what the agent decides. Memory shapes behavior. It doesn't enforce it. Additive has a cost. Every line you add is context you pay for in every session. So the most specific end of the stack got a sharper tool, rules that load only when the agent touches a matching file. For larger projects, you split instructions into a rules folder, one topic per file, discovered recursively, so you can group them by area. A rule with no paths field loads at launch, at the same priority as the project memory file. But add a paths field in the front matter, a glob like everything under the API folder, and that rule becomes conditional. It only enters context when the agent actually reads a file matching the pattern. That's the payoff. Instructions that cost nothing until they're relevant. Personal rules in your home rules folder apply everywhere. And they load before project rules, so project rules take priority. This is the difference between a rule that's always in the room and a rule that walks in only when its topic comes up. For anything that matters in just one corner of the code base, path scoping is how you keep the stack lean. A memory file can pull in other files with the @sign import. It looks like the path scoped rules twin both split a big file into smaller ones, but imports load at launch every time. They organize. They do not save context. Confusing the two is a classic trap. The @sign import expands a referenced file and loads it into context at launch, right alongside the file that imported it. Relative paths resolve relative to the file doing the importing, not your working directory. And imports can import other files, recursively, up to a maximum depth of 4 hops. Here's the trap. Splitting your file into imports helps you organize, but it does not reduce context. Every imported file still loads at launch. That's the exact opposite of a path scoped rule. So the rule of thumb writes itself. Want organization? Either tool works. Want to actually defer context cost? Only path scoped rules do that. Imports always load. 2 practical tools, then the payoff every architect cares about. The memory command lists every memory file, local file, and rules file loaded in your current session. It's your first move when an instruction isn't being followed, because if a file isn't listed, the agent can't see it. The init command generates a starting memory file from your codebase, and if one already exists, it suggests improvements instead of overwriting. Now the payoff. After a compact, the project root memory file, the unscoped rules, and the agent's own notes all re-inject from disk. They survive. But path-scoped rules and nested subfolder memory files do not re-inject. They reload only the next time the agent reads a matching file. So a rule that quietly shaped behavior all session can disappear after a compact until its file is touched again. The rule of thumb: if an instruction must persist, drop the paths field so it loads unconditionally, or move it up to the project root memory file. Specificity has a cost, and that cost is fragility under compaction. 4 assumptions. Each one feels obviously true, and each one quietly breaks your setup. This is what the certification tests, not whether you know the 4 scopes, whether you know how they actually resolve. Mistake 1, assuming the project file overrides the personal file. It doesn't. Both load, the agent reads them together. Mistake 2, assuming the more specific instruction is a hard, guaranteed winner. It isn't. The agent reconciles by judgment, and the documentation says more specific typically wins. If 2 files flatly contradict, it may pick one arbitrarily, which is why you prune conflicts periodically. Mistake 3, splitting a big file into @sign imports to save context. Imports load at launch. Your context is unchanged. Use path scope rules to actually defer cost. Mistake 4, trusting a nested subfolder rule to survive a compact. Only the project root file, the unscoped rules, and the agent's notes re-inject. Nested files and path scope rules come back only when their file is read again. Every one of these is the edge of a mechanism you already learned. Pull it together. To reason about any memory conflict, you hold 3 things, and they all flow from one idea. It's a stack, not a switch. Where the files live is scope 4 layers, from the organization down to your folder. How they load is the walk up the tree, concatenated, the closest one read last. How they combine is additive, everything in context at once. Conflicts reconciled by judgment, the more specific one typically winning. The one hard layer is managed policy, which can't be excluded. At the specific end, path scope rules defer their cost and imports don't. And if you need a guarantee, you leave memory for a hook. The question you started with, which file wins, was the wrong question. The right one is, what's in context, and how specific is it? 5 things to carry with you. 1. Scope is 4 layers, broadest to most specific. 2. The walk concatenates up the tree, and the file closest to you is read last. 3. Memory is additive, not override. Everything loads, the more specific one typically wins, and managed policy can't be excluded. 4. Path-scoped rules defer their context cost, at sign imports don't. 5. After a compact, the project root file, unscoped rules, and the agent's notes survive, nested and path-scoped instructions reload only when their file is read again. It's a stack, not a switch. Thank you for watching the Atlas. If this episode helped, subscribe. There are more in this series on the way. Next up, hooks and permissions. The layer that enforces. The rules that don't ask. The ones that decide what every instruction is actually allowed to do.